us with that is layz3r. Please join me in welcoming layz3r.
Hello, SteemFest. This is my first SteemFest. I understand there was one last year. I didn't make it. I'm regretting that now. This has been a lot of fun so far. I've enjoyed meeting everyone and interacting with everyone, and I look forward to SteemFest 3 already. I'm personally excited about it. So today, I want to talk to you about scaling Steemit with Python and how we at the engineering team at Steemit are using Python every day to help make Steemit even better. Briefly about myself, my name is John Gerlach. I'm on Steemit as layz3r, on GitHub as John-G-G, and also on Twitter as layz3r. You can find me there. I also briefly, before I talk about this stuff, it's only going to be me speaking today, but don't get the impression that it's just me working on this stuff. I have the privilege of being a member of a very smart team of people. This isn't an exhaustive list of the smart people at Steemit. These are just the people that I get to interact with every day, and I just want to say that Ben, who is a recent hire that works on Condenser, is awesome. Donovan is awesome. Gareth is awesome. Johan is awesome. Justin, awesome. Mike Vanderberg, awesome. Tim, awesome. It's a pleasure to work with these people. It makes, I enjoy what I do anyways, but working with smart people at Steemit makes my job even more fun. It's one of the reasons I'm so excited about the future of Steemit, because we are putting together a great team. And also, I want to thank Sneak for helping to assemble this great team of smart people here and guiding us all in our engineering endeavors. So, Steemit, we use Python. We use Python for a lot of things. Some of this stuff is active now. Some of these projects are going to be deployed very soon. If you're curious about any of this stuff, if you don't already know, we're very open source in everything that we do, so you can see what we're doing every day at github.com/Steemit. That's our organization GitHub account, and you can see Hivemind, Jussi, SBDS, Yo, and all the other stuff we're doing, Condenser, everything's up there, and you can watch us in real time. And when you see us doing stuff wrong, you can submit pull request issues and help us to make Steemit even better. I'm going to talk briefly about some of the Python projects we're working on. I'm going to focus on Yo, but I'm going to go over everything here. Currently, it's not released yet, but we are tantalizingly close to releasing Hivemind, which is the Python support for communities on the Steemit platform. I think this is going to be very, very exciting. I was in this room a little while ago, and I heard a talk about the Spanish language community and what they're doing to help curate and promote good content on the Steemit platform, and the whole time I was just thinking about how much communities is going to help these people curate and share reward pools and do all kinds of very exciting things that I think will only help what they're doing become even better. The next project I want to talk about briefly is Jussi. This is a JSON RPC reverse proxy. It currently handles all of the traffic that between Condenser and Steemd, and it's also going to handle all of the future services that we build. This is going to be our single point of interaction with all of the Steemit API services. It's live right now. It's api.steemit.com. That's how you'll talk to Steemd in the future and everything else. SBDS is a project that I think is going to be very useful for developers. Basically, it is a project that follows the blockchain and indexes it in real time, so you don't have to download and sync and run an entire copy of the blockchain yourself. You can use SQL, which I think a lot more people are familiar with, to query it and do fun and cool things with the blockchain. Currently, we're indexing transactions, operations, that kind of thing, but we have plans to expand that to include virtual ops and a bunch of other fun stuff that's going to make that even better. Another project that is even closer, so close to being done and released, is a project called Yo, and this is going to support the notifications for the Steemit platform. So when you want to get notifications on your phone, on your mobile device, via SMS, via email alert, you can configure this for different things they're going to support. If there's from the security perspective, if there's a change in your account, if someone changes your keys, you can get an email about this, you can get an SMS about it. To the more normal everyday social aspects of stuff, follows, mention, things like that. I think it's going to help people stay engaged with Steemit and use it in a more personal way. You're going to interact with it all the time. It's going to let you know what's going on, let you know what your friends are saying, what you're doing, all that kind of stuff. So I look forward to that being released very shortly. So the title of my talk, and one of the things that I'm working on, and one of the challenges that we're facing at Steemit is that blockchains are awesome. We all know that. That's why we're here. But Steemit.com is a website, and the way that you run a website is you have a website, and then you use a relational database as a data store for that website. And relational databases are very good at storing this kind of stuff. MySQL, Postgres, they've been doing it for years. This is what powers just about every website you've ever been to, and it's a solved problem. What is not a solved problem is using blockchains as a data store for a website. And there's some reasons why using blockchains as a data store for a website are, it's just inherently challenging. The first one that comes to mind for me personally is a schema change requires you to recompile Steemd and maybe even have a hard fork to just change the way that you're storing information. If you think about this, any developers in the room, if you use MySQL, if you had to recompile MySQL every time you wanted to make a change, add something to a table, that would not lend itself to developing easily with MySQL. So that's one of the challenges. Also, the way that the blockchain works, if you can think about it in terms of like what a relational database does, you basically have replication enabled always, and it's only over P2P networking, which is not exactly the best, fastest way to do replication stuff. It makes it challenging. You're connecting with nodes and servers all around the world. Configuring them is a little bit hairier than setting up normal relational database replication. Also, and this is maybe one of the most important things, all the writes that you do to the blockchain, they're basically batched in the mempool, and they're committed about every 3 seconds. So you have a built-in delay to all of the writes that you're doing to the blockchain, and that's very different than a MySQL database. Instead of a 1/10 of a second or a 100th of a second or something like that, you're talking about a huge orders of magnitude difference in the response times, and that's not an easy problem to deal with. It's not impossible, but it's not easy to run a website that way. There's just new challenges that we need to solve. Also, we've run into some problems as the website has grown, as our traffic has grown. We've had to add more instances of Steemd to the clusters of Steemd that we deploy. We're currently, at least we have recently been running clusters as large as 50 instances or more. And we've learned, as some of you guys have noticed, that when we start approaching cluster sizes this big or bigger, that there are emerging reliability issues with that. Something having to do with the way that the P2P networking works. If you have a lot of instances that are very close to each other, they're doing a lot of back and forth, and that can increasingly absorb more of the resources that are available for these Steemds, and that makes them like slower in other ways. And so dealing with that challenge is also hard. The nature of Steemd itself, I don't want you to get the wrong idea. I'm not bashing it all. Steemd is why we're all here in this room. It's great. It's what running the website right now. But some things that need to be improved about it, I think, as we move forward and we scale for the future are, right now it's single-threaded, it's cooperatively multitasking design. So this inherently leads to problems like the WebSocket communication that you do with it. It's blocking reads and writes. This is not a problem for a smaller community. This is a bigger problem for a bigger community. We don't totally panic. We've seen these issues coming a lot for a long time. We have a lot of smart people working here. One of them's in the room right now. He's working on the next version of Steemd. It's called AppBase. It's designed to address a lot of these issues and make Steemd a lot more scalable. So like the future is good. It's still bright. So Steemd is in charge of the consensus parts of the blockchain. Well, currently it's doing things that are consensus and not consensus. But the most important single function that Steemd does are the consensus things. How much money you have in your account, votes, things like that. But there are lots of things that Steemd does that are not consensus. And anything that's not consensus that Steemd does are things that we can factor out of Steemd and use other services to do. And that is one of the ways that we're going to address the additional users that we all know are coming to the site and scaling for the future. As an example of this, follows right now. Consensus or not consensus? Follows are not consensus. Tags, anytime you tag a post, is that consensus or not consensus? Not consensus. Trending, all the posts on the website, you see the trending list. Is that something that needs to be in the blockchain and consensus, or can that be separated out? That can be separated out. The reputation scores that are calculated on the website next to every user's name, those are also not consensus. I talked a little bit earlier about communities and the exciting things that those are going to let us do. Communities are also not consensus. So this list right here represents all, it's exciting to me. These are all things that we can pull out of the blockchain, we can do separately, we can scale separately, we can leverage what we all have learned to appreciate about the microservices architecture to improve and scale Steemit. So I want to talk about one example of this that we've done. We're not actually factoring anything out from Steemd, but what we're using and what Jussi does is it's in front of Steemd, and it's accepting all the traffic currently between Condenser and anyone else that's using third-party applications to speak to Steemd. This is live right now. We've written it recently, and it's going to allow us to do a bunch of exciting things that are going to help a lot with our traffic and scaling issues. The first of all, you know that we've recently been the victim of a DDoS attack. That's kind of like a welcome to the internet thing. I think it's not good, but it's just a reality of stuff, and so we need to address it. It's a problem, it's been solved, we just need to build the solution and incorporate it into our platform. We've done that. Jussi, because it's the single point of contact for all of the services at steemit.com, it's a great place to do policy enforcement. How many requests have you made? Do we think that's a reasonable number of requests? Do these requests look like they're designed maliciously to take a long time or do things that normal users probably wouldn't be doing? We can make decisions about that. We can filter it at the edge before you even talk to Steemd or affect performance of the website or anything else. Next up, and this is probably the most important if we're not talking about a DDoS attack and we're just talking about scaling, Jussi does caching, and it does it in a way where we can cache by the service that it's speaking to, and also to go a little bit deeper into the JSON RPC standard. The JSON RPC standard allows you to specify a method and then like the parameters for that method. And the way that we've designed Jussi, we're namespacing all of our methods. So Steemd, for example, it will have the prefix of Steemd, and then it will have the API name, and then the it's API name, and then the method name, and then the parameters to that. And we can cache, we can set different caching levels for any one of those settings. And so things that are called very frequently, the most frequently called that's made to Steemd from Condenser, anytime you load a page or you have a page open on Steemd, it calls something called get dynamic global properties. This just returns some normal information about the blockchain. Get dynamic properties is updated every 3 seconds. But if you multiply the, we get a lot of calls to get dynamic global properties based on our users. Every tab you have open, that's another call that's happening every 3 seconds. Those can be cached. We can eliminate a huge amount of load on the Steemd instances by just caching that. Another big win for us with Jussi is routing, because we have the ability to look into the JSON RPC request and look at who it's trying to talk to and the method it's trying to call on the remote instance. We can do that differently. So for example, when we were addressing the issues that we were having with running such large Steemd clusters, one of the things that we noticed is that the writes were taking a very long time, and the way that everything is architected, the writes could occupy resources that weren't available to something else. So if you have a call or write that's taking 5 seconds, 10 seconds, 30 seconds, that's way longer than it should take, but if it happens to take that because we're under load, that's Steemd resources that aren't available to answer anything else. So one of the solutions that we're able to come up with for this problem was we can route the writes to a different cluster of Steemds that are designed to just be good at doing the writes, that aren't designed to be the general instances that are supporting all of the other traffic. Most of the traffic on the website is read traffic, not write traffic. So you can architect and scale them differently, and you can route the calls to the servers that are designed to address that specifically. Something else I've already mentioned to you, like what our most frequent call is and the time that these calls take. Jussi gives us very good visibility into all the traffic that's coming into steemit.com, so we can just understand very well what's happening. We can diagnose problems, look at things, and make appropriate decisions about how to change things or how to change how we're handling things to best accept whatever particular issue is happening. I have an asterisk next to it because it's not actually in place yet, but a lot of the services that we're building, Yo and other things in the future, are going to support a new authentication that we've designed. Like our version of JSON RPC auth is going to be on the blockchain itself. I don't know that everyone is going to have a use case for it right away, but it's something that we're using, and because we have a single point of access to all this stuff, it's a great place to enforce authentication, which is just going to strengthen our whole infrastructure, the ability we have to do, the ability that we'll have to do that there. So, so you build Jussi, so it does all this stuff. What's the difference? Well, what you're looking at here is a graph of the percentage of calls made to Jussi that are actually handled from the cache that aren't actually speaking to Steemd at all. On the very top, I'm going to show you right over here. This is 0.8, so that's 80%. So what you're looking at is that right now, live on the website, 80% of the calls that you're making, like I said, most of those are to get dynamic global properties. Those aren't even talking to Steemd anymore. We can cache this information for 3 seconds, which is the update for that. So we've reduced 80% of the total number of calls to Steemd just by caching this stuff. And if you're not a nerd, I can inform you about how you should feel about that. But wait, we're not done. What's the difference? I mentioned also, aside from caching, that we can also do routing. We can route the writes to a different cluster of Steemds that are designed to do writes well and not designed, they're just focused on that and they do that very well. What you're looking at here is a graph of response times. This happened to be when we were really struggling, when a lot of you were experiencing problems with things taking a long time on the website. And you can see there's an obvious change in this graph. That happens to be when we deployed the routing to a separate Steemd instance that just handled writes. Below, you're looking at like the average time before the deploy, 36 seconds for a write to take place. The average time after the deploy, when we like set up a separate cluster of Steemd instances that were designed to just do this well, 3 seconds. That's an order of magnitude improvement just by being able to split our traffic and know what it is and send it to the appropriate resources that are designed to handle that well. Again, if you don't know how to feel about that, that's awesome. Okay. So I have something else I want to share. This is the last thing I want to share. It really has nothing to do with my talk, but it's something that I think is very cool. Obviously, I like the engineering part of this stuff, but like, let's not forget that in addition to Steemit allowing you to make money and meet people and interact with everyone and be a part of, like, I think what we all think is going to be a pretty big deal, it's also a great platform for free speech. And you don't have to take my word for that, because what you're looking at here is from our Google Analytics, and you can see that sometime towards the end of October, we have a huge drop in the traffic. And if you can't see, because it's small on the slide, that's from Iran. Iran has cut us off. To me, personally, I think as an advocate of free speech, being cut off by the country of Iran, that's just, that's awesome. That means you've done something, that means you're important, that means that they recognize that what you're doing is valuable to democracy. And anyone that's against that, they're going to cut you off. So it doesn't fit into the other parts of my talk, but I just think this is really cool. And thank you very much.
All right. John, thank you.
And we have some time for questions if anyone has one.
We got 30 seconds.
30 seconds, one question. Just scream it out. I'll repeat it. Anyone? All right.
John, so how did you cut off from Iran?
Sure.
How does somebody, it's not zero, how does somebody get on from Iran given the fact that you've been cut off?
That's an excellent question. If I did know the answer to that, I'd probably...
Repeat the question, please.
Oh, I'm sorry. That's right. So the question was, it wasn't quite zero. How is someone in Iran still managing to get on to Steemit.com? I don't know the answer to that. It looks like there's a few people in Iran that do. VPNs maybe they know someone in ISP, they can plug in on the other side of the firewall, who knows? But it's exciting, and I appreciate that they're willing to make that effort to get on a Steemit, even after their government has said you can't.
All right.
There you
Ladies and
go,
gentlemen,
that's right,
let's hear it
yeah.
for layz3r. Yes.